Hey there, did you work on these before you came to find this answer key video? Okay, let's go. Let's see what you did. They're asking us to convert to radians. Remember in the lecture video, what's the conversion we use? Yeah, pi is equivalent to 180 degrees. So, do you remember what my chemistry professor taught me as I mentioned in my lecture? He said, make this a fraction and you're always multiplying. Now, what do I want to get rid of? I want to get rid of the degrees. So let me write this over here, by the way, to remind ourselves the conversion we're going to use. So if you want to get rid of the degrees, what needs to go in the denominator? The degrees, which means pi goes in the numerator and the degrees cancel, which means you're left with 75 pi over 180. Good? Okay, and now you need to reduce. Tell me what you reduced by. Oh, you reduced by 5? All right, that works. So 5 goes into here, 15. 5 goes into here, 30. 30 what? Sorry, I'm figuring it out too because I didn't figure out ahead of time. That's okay. 5 goes in there, 3, so that's 30, that's 6. Ooh, I think it still reduces, doesn't it? So it looks like you can divide both by 3. So 5 pi over 12. Okay, good enough. Yes? Number 2. What are you going to do first? You're going to make this a fraction. What operation are you going to do to this fraction? Multiply. Okay. Remember, converting to radians, this is the conversion we're using. What do you want to get rid of? The degrees. So what will go in the denominator to cancel it? The 180 degrees. The key with these conversions is putting the units on there. So please make certain you always stay very detailed and write the units. Okay, which means we are going to get 120 pi over 180. Okay, you're like reduced by 10. Got it. So 12 pi over 180 and reduced by 6. So 2 pi over, whoops, sorry, I put an extra 0, didn't I? 2 pi over 3. Good enough. Works for me. Getting the hang of it? Okay. Talk to me about number 3 then. Put a 1, multiply. Some of you are like, I'm just going to put pi on top and 180 degrees. Put that symbol on the bottom so they can cancel. Okay, gotcha. Now, yeah, some of you are like, well, the most challenging part is actually just doing the reducing. I get it, but we can handle it. So let's see. 5. 5 goes into here. Let's see, twice, 7, right? 5 goes into here, 3, 6. Oh, but it reduces one more time, doesn't it? It reduces by 9, so 3 pi over 4. Very cool. All right. How are we doing? Let me do this. Maybe see our work, keep our work separate from each other. How are we doing? Okay? Okay. Let's see what you got on number 4. Yep, over 1. 180 degrees on the bottom, so you can cancel the degrees out. Pi on top. 110 pi over 180. Reduced by 10. 11 pi over 18. Not much more you can do with that. So be it. Number 5. You're like, it's negative. So, it didn't say to write a positive, did it? So don't bother with it. Good, 180 degrees on the bottom, pi on the top. All right, so tell me what this looks like. Negative 225 pi over 180. Got it. So, you reduce by 5. 5 is a good number. So definitely a negative. So what is that? 45 pi over 5 goes into there, 36. I think we've established that enough. Oh, that looks like it reduces again. By 9. Okay, good enough. So then this becomes negative 5 pi over 4. All right, cool. Last but not least, did you get it? Well, pause the video if you didn't do it yet. Okay, you must have done it because you started the video again. So over 1, pi over 180 degrees, boop, boop, cancel those out, right? Okay, so let's see. 450 pi over 180 reduced by 10. Okay. What goes into 45 and 18? Yeah, 3. 3 is not always obvious into 45, but it goes 15 times. Okay. Oh, I guess I could have reduced by a 9. That's okay. I'm going to reduce by 3 again. Hey, I'm going to reduce by what I see. So, reduce by 3, reduce by 3. Good? Okay, that's a 5, by the way, in case you're uncertain. That's 5 pi over 2. Got it. Cool? Okay, hopefully converting to radians has become much simpler for you. Remember the key, this is my conversion. And since I want to get rid of degrees, which has been in the numerator on all 6 of these problems, the 180 degrees has to go in the denominator for all of them. So the degree symbols will cancel out. And that means the pi has to go on top. Yes? Yes. Have fun. Catch you on the flip side.